Hello students, welcome to this video. And in this video, me and Pavan sir, both of us are going to understand differentiation, and in the process you will also understand differentiation. So basically, when you come across differentiation, you may have some doubt about differentiation. Like students do also have those doubts.
Yeah.
So what type of
I have discussed with many students, and the basic problem that students are facing is that they cannot relate the how differentiation is important to us and how we can relate the differentiation with all the concepts that we have learned previously, like geometrically how differentiation can be understand, or we can apply it to some function, how the value can be calculated. So these things are generally students may know the formula, but they don't know why this formula can be derived using other concepts of mathematics.
Okay,
This is one problem.
This is the basic problem with everyone, that we know formula but we don't know the concept behind it.
Yeah.
So should we discuss a question y is equal to x
I
square?
will start with a simple question so that student can easily relate with the earlier learned concepts through differentiation technique.
Okay, so I will take a very easy graph of y is equal to x square, and you have come across that generally people say that dy by dx is equal to 2x. Now, how this has happened? Is there a magic or there is mathematics? So let us try to understand. So what is this? Is dy by dx, which is called differentiation. So we will see everything and we'll try to understand. So first of all, what I would like to tell students that how a chord becomes a tangent.
Yeah, that is related to the application part.
That is related to the application part. So basically, if we take a graph, suppose we take a graph of y is equal to x square, which is something like this. So this graph, I will take 2 points here. One point is A, another point is B, and I will join these 2 points. So after joining these 2 points, this line segment is called a chord. This is basically a chord. So what happens? We can also do one thing. We can drop a perpendicular on x-axis here and drop a perpendicular on x-axis here. So basically this A may have some coordinates. Suppose this A is having a coordinate x comma y, such that x y are related like this.
Yes.
Y is equal to x square, because this is a graph. What I will do, I will take another point B, and let us suppose that this is at some other position which is away from this point at a distance h,
Okay.
horizontal distance. So what will be the coordinates of B basically? So coordinates of B will be x plus h, which will be its x coordinate obviously, because this is x and you are adding h to it, so x plus h, and y coordinate will be accordingly from this formula we
X
can
plus h square.
x plus h whole square, we can write it as we can write here also. Y is
X and x square.
x and x square. So x square are the abscissa ordinate of this point, and x plus h and x plus h whole square are the abscissa ordinate of this point.
Point B.
Point B. So this is a chord we have. Now, how this chord becomes a tangent? This is a question. So basically, when we draw a unique line, so that line should pass through 2 points at least. Otherwise, if we say that there is a point and draw a unique line through it,
It is not possible because infinite number of lines can be drawn from a point.
exactly. So there can be infinite the lines through this point. So first we have to understand that in order to make a unique line, there should be 2 points, not 1 point. So what we will do, we will make this point B come closer to A, and let us call it as B dash. So again, this new B dash is having this perpendicular. If we join A and B dash, we again get a chord.
Yeah, this is another chord, and the 2 points have come little closer.
Little closer. In the next step, what we will do, we will make this point more closer to A.
Okay.
So this is B double dash, and this is a chord, but now it has become very difficult to differentiate between the chord and the curve.
Okay.
So basically, it seems that it is almost overlapping.
Yeah.
But still A and B dash are quite far apart. So what our purpose is, what we are trying to do is, basically we want to take a point which is very close to A, but which is not on A. That means the 2 points are not same, they are different.
They are slightly different. The difference between the two is very small, but we need to have 2 points so that a line can be drawn.
Exactly.
And independent line can be drawn.
Yeah. So in order to draw a line, you need to have 2 points which are distinct, but still those 2 points are very close. So lastly, I am taking a point B triple dash over here, which is very close to A, but it is not on A. Now, if you draw a line joining A and B triple dash, do you know, students, what this line is called? So we all know that this is now called a tangent.
Okay. So I think there are a bit of confusion among the students also that a tangent is a line drawn on a single point.
Yeah.
But what I am getting from here is tangent is not a line drawn from a single point, but it is a line drawn between 2 points, but the 2 points are very close. It seems that they are a single point.
Exactly.
But if we can see this microscopically, so the 2 points have been joined, but the distance is so close that it seems that the line is from a single point.
Yeah, exactly. So roughly we see that to a curve there is a line touching it. So what do we know by touching it? Actually there are 2 points on the curve itself,
Okay.
which are very close, very close, and we are joining those 2 points and extending this.
Yes.
So it becomes a tangent. Now, what does it all means with the differentiation? What is its mathematical value? So basically, the final point P triple dash which we have, this is x plus h comma x plus h whole square. Obviously here x plus h was different, here it is different, again here it is different. So what is changing basically? If you see here, if we are making this b coming closer to a, eventually we are trying to make this h very small. So we can write it mathematically that h is actually tending towards 0.
Okay.
So if it is very small, then they are very close. So it is to be understood that h is not equal to 0. That means A and B triple dash are not the same point. They are different point, but they are very close.
Okay, like we can say that if x, let us say, is equal to 1, then we can say that h is like 0.000001. It is not 0, but it is so close to 0 that we can value wise say that the value is not very different from 0.
Not very. But still we can't take a particular value.
Yeah.
Because infinitesimally small means that whatever value you take, it is smaller than that value. So you can't take any value.
Yeah.
Because any value you will take, you will take smaller than this, that becomes smaller than that, but it will not be 0.
Yeah.
So basically, now if I will draw a triangle over here, I will put a perpendicular from here on this point is C. So in this ABC triangle, if we take this angle as theta, and also if I extend this line to cut on x-axis, then this is also theta. So this is theta because the curve basically which we have is either making this angle as theta, or this is also theta, because you know by transversal corresponding angle, basically these two lines are parallel and there is a transversal, so these two angles are corresponding angles. It is very simple concept. I don't think we need to go into this.
Yeah, definitely.
So now tan theta, if we will take, so this tan theta in this triangle by trigonometry is BC by AC. So what is BC? The difference between the ordinates of the point B and C. What is the ordinate of C? That is x square, same ordinate, same distance from x-axis. And what is the ordinate of B? That is x plus h whole square. So what is BC basically? The difference between these two ordinates, which you can also say y2 minus y1. So you can say as x plus h whole square minus x square. This is y2, this is y1, right? This you can take as y2 and this you can take as y1. Now what is AC? So you can see here AC is h, because this is x plus h. So you can say this is simply h. So this is tan theta. Under normal situation we write it like this. But since we are talking about differentiation, because we are not talking about chord, we are talking about tangent.
Yes.
So what has happened, this point has come closer. This has become a tangent. So in that situation, this h will become almost 0. So we can say that if we are talking about differentiation, so this tan theta, which actually was the slope of the chord, now has become slope of the tangent. Earlier it was a slope of a chord, now it has become a slope of a tangent.
Yes.
So we can write that tan theta is the slope which we generally take as m, which we say as slope of tangent at any particular point on a curve. So this is what we are.
Also, I think we can write this as delta y upon delta x.
Yes.
Because this is the difference in the y coordinate and this is difference in the x coordinate.
X coordinate.
Okay. And so this this is representing the value of slope, that is ratio of change in y upon change in x coordinate.
Right.
Okay.
So slope is basically the quotient of change in y and change in x. So this is what we are having. Now, if this chord becomes a tangent, this is a process of chord becoming a tangent. So when this happens, there is extra condition which comes that h is tending towards 0. That these 2 points A and B are very close. So we can here write limit h, which is tending towards 0, x plus h whole square minus x square upon h. So this is now a slope of tangent. Earlier it was a slope of chord, which has now become a tangent, slope of a tangent, which has come by writing limit h tending towards 0. Now what this dy by dx basically denote, we all know that this dy by dx is slope of a tangent. If we make any curve, then its slope is represented by dy by dx. There is no another definition of dy by dx. All other definitions are related from the same concept. So this is basically slope of tangent. And what we have got, that slope of tangent is this. So now let us come to the point of finding out the slope of tangent.